What is going on YouTube, and welcome back to Cup of Code 01. We are beginning, this is video 1 of a new series called Definitive Guide to Pandas. We're going to be knocking out one of the most utilized libraries, modules that we're going to be using within Python for Python programming. Now, Pandas is essentially, it's an import tool that we're going to use that will allow us to just manipulate data however we need. We can manipulate the data, we can graph the data, we can do more things than you could possibly ever imagine or need to do. It's an easier way and faster way to search data, importing CSV files or tab separated files. And we're going to be using Pandas throughout everything from data analysis to, at certain points, even game development, and then even when we get into finance and so forth. And it's utilized a lot as well in machine learning. There's no point in going through, you can see a book on the bottom there, Python for data analysis. No need to go through that. We're going to be going through all of creating the video series, which is going through all of the code, so no need to be redundant. So let's show you real quick how we do download Pandas if you don't already have it. Again, we know that we utilize PyCharm here at Cup of Code, and so we would go to File and Settings, and it's for me, I'm already defaulting on the project interpreter. And I'm using 3.6.1 Python, but you can come over here to the right, hit the plus button, and then you would just type in Pandas. And it's going to default there, powerful data structures for data analysis, time series, and statistics. You'd hit install package. I already have the package, so it's gonna bring it down, and that's version 0.20.1. But let's say you're using a different kind of developer environment, or you get a pip install error, depending on the version that you're using. All you'd have to do, you just go to this unofficial Windows binaries for Python extension packages, and we could just, there we go, we found it. So we got, no, let me go back up. Let me go straight to Pandas. So we have Pandas here. These are the wheel files, WHL files. That's what we're gonna download it, and then we're gonna install that via command prompt to get Pandas into our system. So the CP is just the complete version of Python that you're using. So if you're using 2.7, 3.4, 3.5, or 3.6, you'd get the appropriate file. And then, of course, if you're on a 32-bit or a 64-bit system, would determine which file you would get. So let's say I'm going to click on this 3.6 or 3.6 rather, and then Windows 64-bit wheel file. That's going to download here. It's going to take a few seconds. What you can do in the meantime, I'm going to open up command prompt, and I'm going to open up my downloads because that's where it's going. And I'm going to right click on the file, hit properties, just so I can get my location here so we can CD into that file location. So I'm going to copy that. I'm going to come back to my command prompt. I'm going to CD to change directory, Control V to put it in. Now I'm in my downloads file. And I'm going to wait until this is done downloading. Oh, we are done. Look at that. So then in the same right click under properties, I'm just going to highlight the actual file. Can't even do that right. Select it all, Control C, come back over to my current command prompt, and I'm going to type pip install Control V, because now it's given the actual file. And remember, we're in the downloads file, so we're in the proper directory. I'm going to hit enter. It's going to run through it. It's going to tell me requirements already met or something like that, because I already have requirement already satisfied, because I already have Panda in place. And you can see it also uninstalled 0.19.2 because we're using the 0.20.1, 0.20.1. And that's it. And then you'd have Python, you'd have Pandas for Python on your system, and you'd be ready to rock and roll. So what we're doing now for this series for the Definitive Guide to Pandas, we're going to start slow, we're going to start fast. Pandas comes with a lot of some data series already installed within it, already built into it, so we can use those to manipulate them to learn how to use Pandas. So first and foremost, what we're going to do is we're going to import Pandas as PD. So importing Pandas as PD just means that we only have to write PD whenever we're calling any kind of a module or a method or a function from Panda. We don't have to write Pandas each time that we're doing it. So we already have the debugger running. So we can start to F8 through pieces here. So here we have back in string mode. So first off, we have df. That's just, I'm using df to mean data frame. You can use whatever abbreviation you want there. So we're just creating a variable equals PD. So we're calling pandas dot the read method. So read underscore CSV. This gapminder.tsv is a file that we can download. This one is not already pre-installed. and then I'm telling Python here with this comma and then sep equals, and then the escape t, I'm telling it that the data is separated by a tab. So it's not, even though it's not CSV data, and you can see we're doing a .tsv for tab separated values, we're still using the read CSV method that exists within the Pandas library. The default for CSV is sep comma, so if we were doing a CSV file, we wouldn't have to utilize that, but we're not. We're actually doing tab separated for this. I'll try to remember to put that gapminder.tsv file in the description of the video. If I don't remember to do that, please somebody drop me a comment to remind me. So the next line, line 5, print df head, open and close parentheses, and then again, I'm just, in this next part here, you'll see a lot of my code. I'm just adding a new line, so when we look at the output, it just looks more readable when we're looking at the output. So for this default head, we F8'd through this default df.head, and you can see here on the side, head is a method. .head is a method. I'm applying it to data frame, the variable that we created, telling it head's always going to give me only the first 5 rows of your data frame. So remember, we're always indexing at 1, so we do have 5 rows, 1, 2, 3, 4, 5, but since we're indexing at 0, it's going to show 0 to 4. And then it gives me my columns on the top. Many times those are called features. So we have country, continent, year, life expectancy, population, GDP per capita. Just take a note of little things like, in life expectancy, the E is capitalized. In the GDP per capita, the P is capitalized. That's important when we're calling those pieces, or when we're manipulating data, that we're as precise as the actual data is. And that's why it's always good just to do a quick head. You could have also done df.tail, and you would have gotten the last 5 rows. And if you want the first 10, 15, 20, you can, in the head, you could put in 10 if you want, and it would give you the first 10 instead of the default of 5. Going through, now what I like to do next is I always do a shape. I want to know what is the shape of the data that I just imported. So this print df.shape is going to do exactly that. What do I have here? I have tuple. It's going to be rows times columns. So it's showing me a tuple because it's in parentheses in the output. You can see here, I'm always pointing at the screen. You can see here we have a tuple of 1704, 6. So we have 1,704 rows of data, and there are 6 columns. And we can see 1, 2, 3, 4, 5, 6. That's appropriate, so we're not missing any columns. And then I just have here that shape is an attribute of the data frame. It's not a function or method. So you don't have to do open and close parentheses when we're calling the shape, because we're applying it as an attribute to the data frame, which is the variable that we created called df. If it was a function or method like head is a method, we have to use the open and close parentheses when we're calling it. And if you ever were doing this and you're not getting what you want, then just add the parentheses or remove it while you're learning to get the data that you wanted to have it. So now I know that there's 1704, 6 rows versus column within this data frame that we're using. So now I have print df.columns. So let's see what's going to come out there. So it gives me an index, and we can see it's essentially a list, the index. We have country, continent, year. It's going to match exactly what's here up type. On the top rather, and then we have our data type. It tells me it is an object. And then we're going to go one more time. We're going to F8 through there, and we're going to get, that was just for the df, the data types after the columns. So it's telling me country is an object, continent is an object, year is an integer, life expectancy is a float, and so forth. You can go through that. So if you remember data types, we have strings, we have floats, we have integers. We're going to be adding 2 new objects into Python when we use Pandas, which is going to be series and data frames. So an object is very close to what Python calls a string. So if you want to equate those two in your head, by all means, you won't be wrong if you do that. And then we're going to F8 through here. What are we going through now? Now we're going through df.info. So the df.info, open and close parentheses. So since we see the parentheses, we know that this was .info is a function or a method that we're applying from Pandas onto our variable data frame. It's just going to give me exactly that, the information for the appropriate. Here I have the index of the column, and then the row piece, and then non-null object, integer, float, yada yada, going all the way down. It even tells us here how much memory usage that we're utilizing to store this data frame within Pandas, essentially within Python, within the memory of the computer. How much are we utilizing? That will come in handy when we get into more of a computer science aspect. So now what we're going to do is we're going to break up the columns by names, positions or ranges. You can do all of those. So first off, I'm just creating a variable country data frame equals data frame, and then I'm calling the index of country from the column. So it's telling me country data frame is 0 and index of 0, and then I'm doing Afghanistan, and we didn't print anything because again all I did was create the variable. I didn't print it yet, but now we can print. Oh, get out of here. Now we can print the country df.head and the tail just so we can see exactly what information it pulled out. So I have here on the right hand side, this is the head, so we can see index of 0, 1 through 4, and then the tail, which is the last 5 values that are within our data that we imported. So we have the tail, we have the tail and the head, and we only pulled out the country. That's all we asked for in the data frame. We could have added multiple ones here, and which we will, and you'll see that it will pull out more information. We can also use the dot notation to call column attributes. So again, here I have the country dot data frame dot is the variable, and the df dot country, and we don't have the parentheses because we're calling an attribute. We're not calling a function or a method. And then we're going to print that variable, the head of that variable that we just created, and let's see what we get out. So now we just have another version utilizing the dot notation. You can see that this most recent head matches the head from above and giving us the first five rows of country and telling us that the data type is an object. So nothing special about that, just using the dot notation to call it instead of the above version, which we were just doing the df in the country. The reason for that is down the road, dot notation is a heck of a lot faster computationally. So when we get into things like the big O notation and so forth, dot notation can play a part. Now I have multiple columns pulled. We can pass the list between. So we're gonna have a list of lists essentially. So I'm gonna F8 through that. All I did was create here in memory space. You can see we have a in the memory we're actually pulling out the country, continent, and year, and we're naming it subset. And then here I'm printing subset.head, so we know we're gonna get the first 5 rows of that particular subset data frame that we're creating. And then we have the tail. I put here 3 in parentheses just as an exercise to get you to understand that you don't have to print all 5. You could print less or more. 5 is just the default. So here we have the head for the subset data frame. So we have Afghanistan, the continent, Asia, and the year. It all pulled it appropriately, keeps everything properly aligned from the data frame. And then we only had the last 3 in the tail because we specified 3 in the parentheses, which also pulled the country, continent, and year. This is all part of our subset data frame. So running through, I have many times you'll want a column by position and not by name. This is usually for more smaller data frames, because when you have massive information, you're not going to really be able to get to position. So we're going to find other ways to extract data, to pull data out of the data frame. So here we have subset is data frame, and then we're giving an index position of 1, a column position of 1, and then so let's just go through it. So we're going to pull that out. What happened here? Subset data frame many times. It's going through. Number 1, not in index. So I'm getting a key error of 1 not in index. All right, guys, welcome back. So I took a quick pause out to see what the hell was going on. I wrote this code. I'd say this file was maybe about 2 weeks old. And since there's been an update on how Pandas was dealing with its column indexing. So no longer could you just call the data frame or the variable, and then the data frame is where we stored our file, by a column indexing. It wouldn't take it as an integer, so I had to use an integer location, which is ILock. If we were not using integer, we could just use location, which is LOC, which is lock, which we already had later in the file anyway, so we just had to call it sooner than later. So as you can see, we are now over here on line 34, and we're going to call the column by its position, not by name, and the position here is going to be index 1, so we're using .iLocation, so the iLocation method to call it. So when I run that, it's just going to change the df variable, and then we're printing it out. So what I'm seeing here now in the right-hand side in the output, I'm seeing country, continent, year, life expectancy, all under just that one location. It's pulling it straight across the side. We're going to F8 through that. And now I can see here, you may not even notice on the bottom, 779.4453.145. That was the iLocation 0, -1. That's doing like a row column. finagling, and the -1 means that we're going from index of 0, and then we're going all the way backwards to that particular row, and it pulled out 779.44. And as you can see, do we have it up top? Yeah, up here. So in index row 0, over here in column -1, we have 779.44, 5314. So it pulled it appropriately. Now we are doing some other ways we can index rows and columns. We can pull out the columns via the range function. So I'm just creating a variable small range, and I'm throwing down list range of 6. So it's going to create that in memory. And then we're going to do the iLocation on the small range, and we're just going to print that real quick. So all it's giving me is a range of the 6 columns, and we know we have 6 columns, but we know it's going to go up to 6, not including 6, so we're going to have 5. So we're going to have 0, 1, 2, 3, 4, 5, or if we were counting numerically, it'd be 1 through 6. So printing out that piece, yeah, not very different than head, but it's just another way to call the different pieces. All I did now is I called out the row or a set of rows using the iLocation. Again, the I stands for integer, location integer. So the ILock is based on the row index position and only takes numbers. ILock only takes numbers. We're going to call it by a name or a label. We're going to use lock, LOC, .loc. Did I have anything else I wanted? Hence the brackets is all I put there. So I have print df was the data frame .ilock, and then we're doing 1200 to 1215. So that's going to print out 15 rows from the location, the integer location of 1200 to 1215. So here we have in this 1200 to 1215, this was the indexing row that Pandas created when we imported it in Python and we imported our data frame. So it's only giving me those rows based on the integer location. Going through now, I pulled out the rows and I specified the column. So now what we did is on the data frame, we did iLocation. We want row 1315 to 1325, comma 2. So that's telling me only column number 2. So let's see what we pulled out. We have 1315 down to 24, but that would be 25 because we're not including 25, so there are 25 rows. And we have 1987 down to 1972. So we pulled the year. So if we look at where we have all of our columns, which we have here, we have year is going to be 2, because again, we go 0, 1, 2. So that's going to be column number 2. That's all we pulled out for that data point there. F8ing through this. Location, now we're doing .lock, .location. It's based on labels, so we're not doing numbers. Now we're actually utilizing labels. So we can index pieces. So data frame .lock 1209 to 1215, and that's what we have here, 1209 to 1215. It just printed out those particular columns and parameters that we called for, and we're going to F8 through this. Let's scroll down. So .lock of 0, so I'm actually pulling out again the 0 row, which is going to be the first row, and it has all the pertinent data tied to the appropriate column. Just a different way to display the data. And then doing the same thing for row 99. We are going, if we went down to row 99 and pulled it out, that's all we're going to be getting in that location. And then we have location 0, 99, 99, 900, 99. So it's going to print out all 3 of those. And you can see we have different brackets because we are pulling out multiple. So it's like a list of lists. So we got row 0, row 99, and row 999, all under their appropriate columns. We're going to F8 through. Now we're iLocation -1. So on -1, what it did is it went to the -1 row. So it went through all of the rows and just went up from the bottom, pulling out all of that data. We can do the same thing for row 1, doing it with tail, df tail number 1, and then we get it printed out just in a different format. Same exact information that we have with the ILock and then the .tail, same exact data. It's just going to be giving it to us in a different format. So I have noticed that their output looks different because they're different types. Oh, that's a good point. I made my own point. The first one, the data type is an object, and then in the second one, the data type is a series. So just by changing, if we were doing ILock or if we're doing tail, we're going to get the difference between an object or a series, which absolutely has its implications. Now we are, whoops, a daisy. Let me scroll down. Now we passed on the data frame .ix 666,666. So we have row 666, 666. And then doing the IX is also just we're indexing out those particular places. Again, just another way to pull data from using Pandas with Python in the particular, this is a tab separated volume that we used for data. Now we're going to pull out rows and columns, pull out the 43rd country. So we're printing the data frame .ix 42. Again, remember we want the 43rd country. We're using 42 because we're indexing at 0. And then we're telling it with the in the column country, pull out whatever value is at row 43, which is an index of 42. Whatever that value is under the column of country, pull that out. And then it pulls it out into memory. We have Angola. And then we're just, same thing we did with location. Where am I here? F8, we did with location. We're going to have Angola, but iLocation gave Angola, and then .ex gave Angola. So you can see here, we just have 4 different ways of pulling out the same value or parameter within row index 42, but row 43 under the country column, which is index of number 2, that particular value, which is Angola. And we pulled that out by the .ix, and then 42 calling the row and then putting in the label. Location, calling out the row, putting in the label. Integer location, which is calling the, which can only take integers, the iLocation. So we're calling the row and then the column. And then the IX is just the same thing as the ILock in terms of what it's calling. So you can see even IX is being done in 2 different fashions. Multiple rows and columns. So here we pulled out 56, 1200, 1456. So we specified the rows that we wanted to pull out, and then we pulled out which column we wanted to go accordingly, the country, the life expectancy, or the GDP per capita. So that's 035 is the index of 035. So we can have 0, 1, 2, 3, 4, 5. So they go accordingly. And then we have here best practice is to use column names if available. Using the column names, one, because it just makes the code a hell of a lot more readable. When I'm coming back to this, again, like I haven't done this code in weeks. When I come, let me go down to the bottom, sorry. When I come down through this code here, and if I just had, so we have country, life expectancy, GDP per capita. We know country, life expectancy, GDP is 035. I know that because I only did that on the previous example. But if I came to this file weeks from now and I see 035, like I have in the code here, I don't necessarily recall what columns that's actually calling. So by actually putting in the labels, country, life expectancy, GDP per capita, it just makes the code more readable. So at least on this line, I can say, oh, okay, I'm indexing out rows 56, 1200, 1456, and I'm pulling the value that is at that locations under the country, life expectancy, and GDP per capita column or feature, pulling out that value for that feature. So that's going to be it for video 1 on Definitive Guide to Pandas. All I wanted you to do with this is, you don't have to memorize all of this crap, is just to go through and understand loading in the file, creating it into a variable, add the object into a variable, and then beginning to apply different methods or different attributes onto that data to start to tease out pieces. Play with it, try to index things. They did just update the code, which is going to make it more interesting. We'll see what happens on the next files. But stay tuned, and we'll hit out day 2 of Definitive Guide to Pandas just soon. Take it easy, guys. Thank you.